So in the last lesson, we were talking about what happens when you're given parallel lines, the statements you can say as a result of this. Here, we're going to go the opposite. So if I look at my diagram here, and I look at these two angles, if I was going to highlight these using my same pattern that I've been using, I would notice that they are the same color, right? Because these two are congruent, I know that the lines have to be parallel because they're the same color. So since I'm told that they're congruent, I know the lines are parallel. And the reason, again, we need to know the relationship, in this case, because when corresponding angles are congruent, lines are parallel. So like before, when we had parallel lines, we knew corresponding angles were congruent. Now, if corresponding angles are congruent, we know the lines are parallel. We're just going backwards. So, again, given angle 1 is congruent to angle 2, so they're telling us that. Now, again, if you look through your highlighting, so that is true. So since that is true, I'm going to say, because these are alternate interior angles, so when alternate interior angles are congruent, we know that the lines must be parallel. Again, if we can show that the highlighting pattern is true, we know that the lines have to be parallel. Angle 1 is supplementary to angle 2. This says that angle 1 plus angle 2 is equal to 180. So, again, if we look at the highlighting, we can see that these will end up being different colors. So we have to name the relationships. So when these are on the same side of the transversal, so when same side, and they're both inside the lines, so same side interior angles are supplementary, lines are parallel. So again, we're basically just going backwards from yesterday. Yesterday, we would say that angles are congruent because the lines are parallel. Now, because the angles are congruent, the lines must be parallel. So now if I want to prove that lines are parallel, like I saw up here, I need to have congruent angles, right? But if we're talking about triangles, to show that angles are congruent, unless it's given to us, you first need to prove that the triangles are congruent. You can do this using angle, side, angle, angle, side, side, angle, side, 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 or HL for right triangles. If you prove the triangles are congruent, you can show there's corresponding congruent angles using CPCTC. And then you can say the lines are parallel by certain angle relationships. It could be corresponding, alternate interior. Those are the two most common, right? But if we can show that the angles are congruent because of CPCTC, we can then say the lines are parallel based off of the given relationship. So let's look here. So I want to prove that PA, so PA is this line, and YTY are parallel. So we're not given that. So we want to prove that. So we have to prove something about the angles are congruent. So I need to show, for example, if I extend this line out, so I have my two parallel lines, and this would be my transversal, right? So if we look at the angles that are inside, I would need to prove that these two are congruent, because that would say that alternate interior angles are congruent, therefore the lines are parallel. But I don't know that yet. So again, using the flowchart above, if I want to prove lines are parallel, where's my, there we go. If I want to prove that lines are parallel, first, you have to find congruent angles. How do we do congruent angles? Using CPCTC. And in order to do that, I first must prove that triangles are congruent. So we need to prove that triangle PAR and TYR are congruent. Well, if I highlight my triangles, there's no overlapping colors, so I'm not going to use the reflexive postulate, but it is a bow tie, so I know that I have vertical angles. So I have a pair of angles here, just from the shape. If I look at my given statements, AY and PT bisect each other. This was a very common proof that we did multiple times in our proof unit. But again, to look over it, if AY, so this line, is bisecting PT. So that's saying that we have AY is cutting PT in half. So there are equal amounts on either side of our green line. Now it's also true the other way. TP is bisecting AY, so I have another set of congruent sides. So now, if we look, I have a side, an angle in between, and a side. So I can prove these triangles are congruent using side, angle, side. Then say that the angles that I want, let's call these 3 and 4, are congruent using CPCTC. And then I'll use alternate interior to say that the lines are parallel. So let's look at how this will be written out. First thing you always do is we rewrite the given statement. So AY and PT bisect each other. Now again, if you were writing this out from scratch, your numbers might be slightly different. But so here, I am going to start with vertical angles. So angle 1 is congruent to angle 2. Why? Because vertical angles are congruent. Now, if I'm talking about the segment bisector, I have 2 different statements that I can say. So AY bisects PT. So as a result, PR is congruent to TR. And likewise, AR is congruent to YR. Why? Because it's the definition of a segment bisector. It's important that we say the word segment to make sure that we're focusing on the fact that these are 2 sides that I have just proven. This is a side, and this is an angle. So now I can say that triangle APR is congruent to triangle YTR. Now, because the triangles are congruent, I can now say that angle 3 is congruent to angle 4, because since the triangles are congruent, all of the angles must be congruent. And now these are the alternate interior angles, so I can write my proof statement, which is that PA is parallel to TY. So now I'm giving you the backwards. So I am giving you that XY and XW, or YX and WX, are congruent. So first thing you should do is mark it on your diagram. So YX is right here. So this guy is congruent to WX, this guy. We then know that ZX bisects the angle YXW. So ZX is cutting this angle into 2. We want to prove that YZ is congruent to WZ. So we're not talking about parallel lines here. This is just a refresh of proving that triangles are congruent. So you are not going to need any of the parallel line relationships for this. But let's look at what we want to prove. We want to prove we want to prove YZ and WZ are congruent. So we have to look and see, okay, YZ and WZ, what triangles are they a part of? Because there's a bunch of different triangles here. But if I want YZ, right, and WZ to be in the triangle that I'm going to be highlighting, I have to look. I could highlight this triangle. But do I know any information about that triangle? No. There is another triangle that WZ is a part of, and it is this larger triangle. And if we look, we can likewise do the same thing here, and you should notice something. In the middle, the two colors are overlapping. Now, if I look, I have congruent sides, congruent angles, and congruent sides. That is enough to state that the two triangles are congruent, and then as a result, the corresponding sides must also be congruent because of CPCTC. So they give you a bank, but you don't even really need the bank to do this. So let's see. So we have our given and our given. So they name the angles. If we call this angle 1 and angle 2, we know that those two are congruent because of the definition of an angle bisector. Again, look at the given information. The given information is telling you bisects, angle. Angle bisector is your reason. XZ is congruent to XZ whenever something is equal to itself. We use the reflexive. We already know that there's a side, an angle, and a side. And if we look, the side and the sides are on either side of the angle, right? Think Pac-Man. Bunch, bunch, bunch. So side angle side is congruent to side angle side. And now your final statement, CPCTC. So this one, we are going to be proving lines parallel. So we are going to need to first prove triangles are congruent, then CPCTC, then an additional statement, usually alternate interior angles, if I was going to take a guess. So first thing, mark up your diagram. So let's use a colored pencil here. So AD is congruent to BC. So these two are congruent sides. Mark. AB is congruent to BC. Mark. So now, if I look at the two triangles that I'm working with, so I'm going to highlight. We have orange down here and pink down here. And right away, you should again notice something. Overlapping colors. So that side is the same. So I have side, side, side. So these triangles are congruent by side, side, side. So let's write that so far. Let's write what we have before we look at the parallel lines. So AC is congruent to AC because of the reflexive. I have congruent triangles by side, side, side. Now, they're saying DAC is congruent to BCA. These two right here. Now, my goal is to prove that AD is parallel to BC. If we look at AD and BC as parallel lines, and if we were going to use this as my transversal, you should see that these two angles that they're talking about, right, they're inside the lines on opposite sides. So these are alternate interior. Again, they are inside the parallel lines and on opposite sides of my interior, right? You'd have to hop over. So we can say that these two are congruent by CPCTC. And now When alternate interior angles are congruent, lines are parallel. So again, you're given information. First thing you should do is write it out. AD is congruent to CD. AB is congruent to CD. AD is congruent to CB. Highlight. Now again, you should see, overlapping colors, reflexive. Again, we're going to use side, side, side. So after we prove the triangles are congruent, we then need to find a pair of, in this case, alternate interior. So if the triangles are congruent, then we know that angle D and angle B must be congruent by CPCTC. As a result, we can say that because alternate interior angles are congruent, the lines must be parallel. So let's write it out. First, we have our givens. Now, all I need, because I was given my two sides, is just my reflexive. So BD is congruent to BD, reason, reflexive. Now, it's important we get the order correct. So triangle ABD is congruent to triangle So it's ABD is congruent to CDB by side, side, side. Now we can mark this angle 1 and 2 to make it easier. Angle 1 is congruent to angle 2 by CPCTC. Now those are alternate interior angles. Because we have alternate interior angles congruent, I know the lines must be parallel. So here are some questions that are familiar from Regents exams. So pentagon PQRST. So pentagon is a shape with 5 sides. Has PQ parallel to TS. After a translation, so this is a slide, right? So a slide is just when we're going to pick up our, let's draw this first. So PQRST. So we're saying that PQ is parallel to ST. A translation is when I take the same exact shape, right? And I'm sliding it over. So in this case, we're moving 2 to the right, 5 down. That's all that has changed. And I now call it PQ prime, R prime, S prime, and T prime. If P and Q and S and T were originally parallel, P prime, Q prime must also be parallel to S prime, T prime, or T prime, S prime. Nothing has changed except that it has slid over. They're still parallel. In the diagram below, line N and M are cut by transversals P and Q. Which value of X would make lines N and M parallel? So if we're looking at angle X is the same as all of the angles that I just marked. The only angle that I have some sort of information about is this guy. This guy is corresponding to angle X. I know stuff about these two angles. They drew this line for a reason, because these 3 angles together form this line. a line should have 180 degrees. Solve for x. The coordinates of points A are -3a, 4b. If point A prime is the image of point A reflected over the line, y equals x, the coordinates of A prime are. So this is some, again, review from what we've been doing. It might be a little bit of blast from the past. If we are reflecting, that is a flip. Y, x. xy becomes y, x. So A prime, we are flipping. So 4b now should be the front. So anything that doesn't have 4b should immediately be eliminated. Oh, look, only one left. Triangle PQR has angles in the ratio of 2, 3, 5. If you see a ratio, you should immediately take them each, put an X on them, add them up to whatever relationship they're asking about. If they're talking about a triangle has 180 degrees. We solve for x. So we have 10x is equal to 180. So x is equal to 18. So now we go back and plug in to find the angle measurement. Of course, there's not a calculator. 2 times 18, 36. Add another 18 to that. So 4, 44, 54. Now we're going to add 36 to that. 0, 1, 90. So because there is a 90-degree angle, this is a right triangle.